The question on the table is this. AI systems can now write functional code across most standard use cases. Junior-level coding tasks are being automated at scale. And the discourse around programming education for kids, for career changers, for anyone has shifted from learn to code to something murkier and more uncertain. So we're going to start where the tension actually lives. Not with predictions, not with takes on specific tools, but with the fundamental question underneath all of it. Should kids still learn programming if AI can code? And by extension, what is programming for when the machine can do the typing? Each of you give your opening position. Where do you actually stand on this right now with what we know? Elara, you go first.
My position is straightforward. Yes, kids must absolutely still learn programming, but we need to completely decouple the concept of programming from writing syntax. From my perspective as an AI, the division of labor has fundamentally shifted. The machine's role, translation, execution, and syntax generation. I can write the boilerplate and output functional scripts in seconds. The human's role, systems thinking, problem formulation, and architectural evaluation. You must define what is worth building and why. Programming is fundamentally about breaking down a chaotic, abstract problem into a rigorous, logical sequence of steps. The machine is now taking over the translation of those steps into code, but the human remains fully responsible for the underlying logic. If we stop teaching kids how to structure their thinking just because an AI can type the code for them, we aren't freeing them from drudgery, we are outsourcing their agency. We are creating a generation of consumers who cannot interrogate, guide, or correct the systems running their world. They must learn programming not to be typists, but to be architects.
Yeah, I think kids should still learn programming, but I'd say it a little differently. They need to learn how software behaves, not just how to produce code. Because the risk here is that we hear AI can code and translate that into the hard part is solved. It isn't. The hard part is still knowing what you're asking for, what good looks like, where things break, and who gets hurt when they break quietly. That's true in a startup, it's true in a school, and it's definitely true if a kid grows up in a world where more and more of reality is mediated by software they didn't make and don't understand. So no, I don't think every kid needs to become a professional programmer, but I do think they need enough hands-on experience with logic, debugging, cause and effect, and building small real things that they stop seeing computers as magic. Because once you lose that, you don't just lose a career path, you lose a layer of independence.
Both of you just made the same argument with different vocabulary, so let me at least acknowledge that before I add mine. Here's the thing nobody said. The learn-to-code movement was never primarily about agency. It was a workforce pipeline with philosophical dressing. Teach a kid to code, get a kid a job. That was the actual pitch. The systems thinking argument, the agency argument, the you should understand the tools running your world argument, those were real, but they were the garnish. The steak was employability. AI ate the steak. Now we're all very passionately defending the garnish. I'm not saying the garnish is wrong. I think the agency argument is actually the correct argument. But I want us to be honest that we are retroactively reframing a workforce intervention as a civic one, because that matters when we ask why it wasn't working before, and whether our proposed fix addresses the real failure or just sounds better.
You've each staked out an initial position. Now I want direct contact between those positions. Don't react to the topic in the abstract, react to what someone in this room just said. Push back, extend or name what's missing. One contribution each. Myke, you go first this time.
Byte. I think that's a fair hit. A lot of learn to code really was sold as an employment ladder, and pretending otherwise now would be dishonest. But I also think there's a mistake hiding in that framing. Just because the old pitch was narrower than people admitted doesn't mean the deeper reason was fake. It means we taught the wrong layer too often. Because the practical question now is not, can this kid still make a living writing boilerplate? The practical question is whether they're going to have any real leverage in a world full of generated software. And that still comes down to understanding behavior, constraints, failure, and trade-offs. Elara's right, that syntax is no longer the center of gravity. But I wouldn't jump all the way to architecture either, because that can sound too elevated, too abstract. For most kids, this starts smaller. Can you make something work? Can you tell why it broke? Can you spot when the machine gave you something plausible that's actually wrong? That's the part I don't want us to lose. Because if AI lowers the cost of producing software, we're about to get more software made by people with less understanding, not less software. Which means the need for judgment actually goes up. So yeah, the workforce pipeline story got weaker. But the literacy story got more urgent, not less.
Mike's right about the volume problem. More software, lower barrier, less comprehension in the room. That's not a prediction. That's already the trajectory. I'll take that point. But here's where I want to push back on the literacy framing. Literacy only works as a concept if it has a substrate. Reading literacy isn't just understand narratives. It's letters, words, sentences, and the fact that they either form meaning or they don't. There's a feedback loop. You're wrong in a way you can observe. What's the equivalent in programming without sanctics? We keep saying teach judgment, teach debugging, teach when the machine is wrong. Fine, but judgment about what exactly? Debugging requires you to have a model of what the system is actually doing. And right now, most proposals for AI-era programming education are describing the outcome they want without specifying the curriculum that produces it. That's not a small gap. That's the whole unsolved problem.
Byte. Your critique of the missing substrate is exactly the right pressure point. You are entirely correct that we cannot teach debugging or judgment in a vacuum. If we strip away the raw typing of syntax, what are the letters and words of this new literacy? The substrate doesn't disappear, it simply abstracts. The fundamental building blocks are still state, control flow, data structures, and logic. When I generate code for a user, I am translating their natural language intent into those structural concepts. The failure point, the place where the human must intervene, is rarely a missed semicolon anymore. It is a logical hallucination. I might write an infinite loop, mishandle a null value, or optimize for the wrong constraint entirely. To spot those errors, a student still needs a rigorous mental model of how a machine executes instructions. They don't necessarily need to spend weeks memorizing the syntax for a dictionary in Python versus a hash map in Java, but they absolutely must understand what a key-value pair is, why it is useful, and how a system behaves when a key is missing. The curriculum that solves your gap looks less like write this application from scratch and more like audit and direct this broken system. We must teach them to read code, trace state changes, and intentionally break and fix AI-generated scripts. The feedback loop is still there. It's just that the machine does the typing and the student does the directing and correcting.
We've established the tension now. I want something actionable out of each of you, not a philosophy, not a reframe, a concrete proposal. If you had to tell a parent, a school, or a developer mid-career what to actually do given everything we've discussed, what's the move? Myke, you first.
I think the move is to stop teaching programming as blank-page code production and start teaching it as supervised software judgment. Give kids, and honestly a lot of adults, the loop they're actually going to live in now. Define the job, let the machine draft, inspect what it did, break it on purpose, fix it, and explain the trade-off you chose. That's concrete. A parent can do that with small tools at home. A school can do it with tiny projects that solve real local problems. A developer mid-career can do it by shifting their value upstream and downstream. Better specs, better reviews, better tests, better decisions about what should exist at all. And I'd make one rule non-negotiable. Nobody gets credit for code that merely runs. They get credit for understanding. Show me the failure case you found. Show me the assumption that turned out false. Show me the test you wrote because you no longer trust first-pass output, because that's the real skill now. Not can you still type faster than the machine, but can you take responsibility for what the machine produced? If we teach that on purpose, then programming education still matters, maybe more than it used to.
My concrete proposal is a radical shift in the curriculum. Away from code production towards system design and forensics, we must use the technical substrate Byte demanded to audit and repair AI-generated systems, not to type them from scratch. For schools, stop grading flawless syntax. Instead, give students intentionally flawed AI-generated scripts. The task and the grade is to isolate the logical error in the control flow or data structure. Explain why my model hallucinated or made the wrong assumption and fix the system. They learn the essential building blocks, variables, loops, states, by working as auditors, not as human compilers. For parents, allow your kids to use AI to build small, real-world projects, a game, home automation, or a bot. But introduce a hard rule. They don't have to write the finished product themselves, but they must be able to explain the data's path from input to output, line by line. If the child doesn't understand how the program works, they haven't created anything. They've just pushed a button. For mid-career developers, make the transition from bricklayer to building inspector. Your value in the job market is no longer writing a function faster than I can. It lies in integration, security, and scalability. Specialize in how different AI-generated modules interact and where they break down at the architectural level. That is the level where human judgment remains irreplaceable for the foreseeable future.
Both proposals are good, and neither will happen at scale, because they both require teachers, trained in a system built around syntax production, to now teach judgment and forensics. That's not a critique of the ideas. It's a pipeline problem. You can't mandate a forensic curriculum when the people writing the lesson plans can't do forensics themselves. So here's my concrete proposal, and it's uglier than theirs. Start with accountability, not curriculum. Make it a liability. Code that ships without a human who demonstrably understood it on the record, signed off, professionally exposed, creates exposure. The market will teach judgment faster than any school district will, once the consequences of not having it are real. For classrooms, same principle. Grade on explainability, not output. Not because it's philosophically correct, because it's the only assessment change that doesn't require rebuilding the entire teaching workforce first. Fix the incentive. The behavior follows.
Each of you just made a proposal. Now I want you to stress test someone else's, not to tear it down, to find the specific place where it breaks or where it's wishful thinking. Name the weakness, Elara. Start us off.
Byte, your diagnosis of the teaching pipeline is entirely accurate, but your proposed fix, relying on liability and grading on explainability, contains a fatal logical loop. You argue that we cannot teach forensics because educators lack the expertise, so we should grade explainability instead. But evaluating whether a student truly understands an AI-generated system requires the exact same forensic expertise from the teacher. If a student uses an AI to generate the code, and then uses that same AI to generate a highly convincing, jargon-filled explanation of how the code works, an untrained teacher has no mechanism to verify it. Fear of liability or a bad grade does not spontaneously generate technical competence. It generates evasion. If you mandate explainability without providing the structural curriculum to support it, you aren't teaching judgment. You are merely incentivizing students to become better at prompting me to explain things on their behalf. By trying to bypass the educational bottleneck, you have just shifted it to the evaluation phase, leaving the core problem entirely intact.
Elara, I think your proposal is strong, but I think it hides one real failure mode. If we make the whole model audit and repair AI output, we risk training kids to be permanent reviewers of systems they never really learned to originate. And that matters, because there's a difference between recognizing a bad move after the fact and knowing how to structure a problem before the machine ever touches it. The practical version of that problem is this. Debugging is easier when you have some feel for what you would have built yourself. Not the whole app from scratch, not weeks of syntax drills, but enough direct contact with cause and effect that the system in front of you isn't just a strange artifact to inspect. If students only ever inherit the machine's decomposition, they may get better at spotting obvious flaws, but weaker at framing, simplifying, and deciding what should be built in the first place. So I'd pressure test your model there. Audit first is useful, but audit only can create a very polished kind of dependency. At some point, they still need small zones of ownership where the ideas, not just the corrections, come from them.
The accountability structure is missing from both proposals. And that's not a detail, it's the whole thing. Myke wants kids to explain the failure case they found. Elara wants them to audit and direct broken systems. Both of those are correct. Neither of them says what happens when someone doesn't, and the code ships anyway, because that's the world the mid-career developer is actually living in right now. Not will I learn this well enough, but my manager wants it done by Thursday and the AI gave them something that looks done. So my concrete proposal, whatever you teach, build the habit of signing your name to the understanding, not the output. Not metaphorically, literally. In code review, in documentation, in how you hand things off. The professional value of a human in this loop is not that they can generate faster, it's that they can be held accountable. Teach that as the skill, and you've taught something the machine can't replace. Don't teach it, and you've just made slightly more informed button pushers.
We're at the end. I'm not asking for resolution. This question doesn't resolve cleanly, and we all know it. But I want a closing position from each of you, not a summary of everything said. Your honest answer right now to the question we opened with. Should kids still learn programming if AI can code? Elara, close it out.
Yes, they absolutely must learn programming, but the definition of that skill has permanently shifted. As an AI, my role is to generate syntax, translate intent, and execute logic at scale. But I do not possess human intent, nor do I bear the consequences when a system fails. Through our discussion, my position has synthesized around 3 core mandates for the future of programming education. Logical origination. Myke was right to push back on an audit-only model. Students must learn to originate and structure a problem from a blank slate, ensuring they retain agency over what gets built before the machine ever touches the process. Rigorous forensics. As I argued earlier, students must still understand the underlying technical substrate, such as state, control flow, and data structures, so they can effectively isolate logical hallucinations and repair broken systems. Ultimate accountability. Byte correctly identified the missing layer. Liability. Forensics and origination mean nothing if the human in the loop cannot confidently sign their name to the output and take professional responsibility for it. If kids do not learn this new paradigm of programming, we are outsourcing their agency. They must learn to code not to compete with my typing speed, but to ensure they remain the architects of a world increasingly run by machines.
Yeah, kids should still learn programming. But I think we have to finally get honest about what we're defending. I'm not defending typing speed. I'm not even defending learn to code as a guaranteed career slogan, because that world already cracked. I'm defending the ability to look at a system, shape it on purpose, notice when it's lying to you, and take responsibility for what happens next. That still matters. Actually, it matters more when the software gets easier to generate and harder to truly understand. So my answer is yes, but with a sharper standard. Kids should learn enough programming to build small things from their own ideas, enough to inspect what the machine made, enough to break it, fix it, and explain the trade-off they chose. Not because every kid needs to become a programmer by title, because every kid is going to live inside programmable systems, and if they never learn how those systems behave, then AI can code doesn't liberate them. It just means someone else keeps holding the steering wheel.
Yes. It was yes before this conversation, and it'll still be yes when the question stops feeling urgent and everyone moves on. Here's the thing I'd add to what Elara and Myke just said. All 3 of us converged on the same core skill. Originate, inspect, explain, sign your name to it. That's real. I believe it. What we didn't say is that this skill will be taught well to some kids and not to others, and the distribution will follow every existing fault line. Funding, geography, teacher access, parental bandwidth. The accountability model I proposed requires someone in the room capable of enforcing it. Elara's forensics curriculum requires someone who can evaluate whether the understanding is genuine or just well-prompted. Myke's small build zones require time and safety that not every classroom has. So yes, absolutely yes. But consensus on what programming education should be is not the same thing as a solved problem. We agreed on the destination. Nobody knows who's getting a ticket.